present the last talk of today. So this is a special session in honor to Jacob Palis. So Lorenzo Díaz is going to give a talk about his work and his contribution. Thank you, Lorenzo.
Well, good afternoon. Well, I would like to thank Enrique for not coming. Okay. But anyway, it's a great pleasure to stay here and to talk about the work of Jacob. Well, this is a caricature that Andre Nachbin made. I don't know exactly when. I guess that was with the occasion of the Institute of the Millennium or something like this, INSTMAP, where that Jacob organized. This was a very important project for the mathematical community in Brazil. It stopped 6 months ago, something like this. And well, Jacob make a huge project, putting a lot of people together. Well, this is fortunately, it is relatively easy to translate the joke because they say that I cannot read, my God. Some people believe on palliative, others believe on palliatives. I don't know. Well, it's impossible to translate the jokes. But Jacob was really always going forward, pushing forward with a lot of energy, trying to put the people together. Well, let me continue with some words by Etienne Guise. You have there the version in French. Well, I think that here we are talking about the 60s. He said, well, that there was a group of people, including Jacob, that, well, they had the possibility of having brilliant careers abroad, but they returned to Brazil because, well, they believe in the possibility of developing science in the country. And then I think that we are here. I think that essentially, thanks to the effort of these people made 60 years ago or something like this. Well, recently I wrote several texts. One a text for the Mathematical Union, another text for the Brazilian Mathematical Society about Jacob. And then when writing this text, I note that many people were not aware about the conditions that we have in Brazil 70 or 60 years ago. Well, let me first, here is a tribute to say the beginning of the beginning. In this photo, you can see Mauricio Peixoto, left, Lindolfo Carvalho, always smiling. I think that Lindolfo is the most smiling people that I know, perhaps with Jacob, they are in competition. Steve Ismail. Well, this is perhaps one of the first visits of Ismail to Jacob. But I wanted to include in this photo the figure of Elon Lima. Elon Lima was very important to many people. Well, I think that he developed a fantastic work, this Project Euclides, writing book in Portuguese. Well, I think that Elon was the person that was responsible that Steve Ismail came to Brazil. And well, perhaps this is the beginning of the school, of the Brazilian school dynamical system that you want to say. And this is, well, perhaps after we are talking about 71, when you can see in the photo, my God, I forgot the name. René Tom, Jacob Palis, a person that I don't know the name. Lelio Gama, okay, thank you, Cesar. Mauricio Peixoto, they organized this conference in Salvador. You can see here the volume of the conference. If you look to the index, you can see there the names of many important people that come to Salvador. Well, organizing this conference, there is one of the favorite stories of Jaco that he said that one day returning from the work in the old IMPA in the center of the city. I think that he said, "You can help me a little." He met, I guess, is not the head of the FINEP or something like that, and the person like Jacob was there, tired with many books, and the head of the agency asked, "What are you doing here with this Saturday in the morning with these books?" And Jacob said, "Well, I am working harder with my students, and we wanted to organize a conference, blah, blah, blah." And then the head of the FINEPA said, how many money do you need? And then Jacob was the beginning to get the support for this conference. Jacob loved to tell us this history. And then, well, say you said it's difficult especially for the young people, to have the idea of the evolution of science and dynamical system in Brazil. If you go back to the 70s, 74, we have a dictatorship, started in 74, if I remember correctly, and this finished in the 85. Well, with the movement of direct just asking for direct elections, and the tragic event of when Tancredo Neves, that was elected president, passed away before taking office. And this was from 74 to 85 was a very difficult period. I will return to this later. And then, well, in that moment, Steve Ismail arrived to Rio. He spent, I think, 1 year in Rio. You can read the memories of Ismail when he explained that he proved the Poincaré conjecture while surfing in Ipanema. And well, this is very funny history. You can go to the books. But well, at this moment, well, we have one of the key moments of the dynamical system in Brazil, and also in Rio was when Ismail invented or discovered, you can decide your favorite word, the homoclinic phenomena and the horses that Anna referred in her talk. Okay, well, let me return to the situation, because many people think, well, you see the development of science in Brazil. This is special for the young people. From 82 to 95, we have a chronic hyperinflation. Perhaps many of you are complaining now of 5% of inflation, 10% on inflation per year. But we are talking here, from 82 to 84, about 100 to 250% inflation every year. In 87, 400%. Well, you can read the numbers. I don't know planning to read all the numbers. It's very difficult to think about 1,700% of inflation in 1 year. Was very hard periods. And I can remember correctly, during that period, we have 4 different currencies. And then also, we have very strange histories that perhaps for the younger people it is unbearable. But we have this process when during the Plano Cruzado, the prices were frozen and there was no meat in the supermarket, and the government took some cows from the field. You can see here, and this finishes with the impeachment of Collor de Mello by corruption. We are talking about a period of about 5-7 years that were completely crazy. And then, well, I like this. This is one of the books in our poster is due to Millor. That Gordon Metz, I think that he summarized quite well what happened in that year in Brazil. And then under these conditions, we have that Jacob and other people develop dynamical system and science in Brazil. Well, Jacob was a great enthusiast of organizing conference. He started to organize a series of conferences in the International Center of Theoretical Physics and in Trieste, I think that about 81 is correct, is that? He organized many conferences. I can remember Paulo Sad, that he referred to this conference. Well, it's difficult to translate this. In Brazil, we have the say tren de alegria. How do you say happy train? And then when you have a process with many people have extra salaries, are promoted, and then Paulo Sá refers to the conference organized by Jacob at ICTP of the Boeing da Alegria, the happy Boeing. Then many people go there. The conference interest were fantastic events. I think that the people that participate in this conference have excellent memories. And there is a photo here that I like very much. In this photo, well, all times you can see Jacob. Well, the photo, the quality is not that good. You can see Jacob, Floris Takens, Ricardo Mañé. You can see Patrick Bonquer, Artur Lopez, Paulo Sad, that he also participated in the Boeings also. And Carlos Gutierrez. And this, well, this is very nice because if you go now to Trieste, the train station is so depressing that is, but okay. And then, well, Jacob organized many conferences in Trieste. He was also promote many conferences in Rio, many quadrennial conference. When he was in charge of the International Mathematical Union, he also used the meetings of the union to organize mathematical conference of excellent level. He was also always very involved in promoting mathematical interchange and relations, blah blah blah. Well, this is a conference that Stefano Lusato gave at ICTP about, the title describes well the spirit of Jacob of constructing academical bridges, between different groups, nations, continents, or whatever. But in the photo, you can see Abdul Salam, Jacob, and Jacob Sinai. Sorry? Who is Stefano? Stefano Lusato. Well, okay. Okay. Well, okay. Well, I don't know for the people of my generation, perhaps for the people about 50s, the books of Dynamical System of Jacob that he wrote in collaboration with Wellington de Mello. In the photo, I think that this book was our first book in Dynamical System. I think that times changed. Now there are many books, but this book, I guess, that was played a fundamental role in the education and the dynamical education of many people. Well, now let me try to talk a little about mathematics to give some context. Sorry. Well, typically when one try to organize the dynamic thesis idea that perhaps also you call Conley, but you try to organize the dynamics using the hyperbolic periodic points when you have this point, and then you may have the attractors, the repellers, and also you have the saddles. And then the next thing, you are in a hyperbolic context, you have the invariant manifolds, and then you consider the intersection between these invariant manifolds. Okay, when you have an attractor, well, an attractor is an attractor, and then it attracts a neighborhood of it. And well, they are very important, but you have several kinds of attractors besides the trivial one, which are the periodic attractive points. You may have a Nosov attractor, Plicking attractor, DA attractors, many different types. And then you can also consider saddles, which do not belong to an attractor. When you are in dimension 2, you have that all the saddles that you have are the same type. They have one stable direction and one unstable direction. But when you go to dimension when you go to dimension 3, I am not planning to go to higher dimensions. The dimension 3 is good for me. It's enough. You may have two types of saddles of different types. You may have a saddle that has two stable directions, as the one in the left, or you may have a saddle with two stable directions. And then you can think about the interaction between saddles. And then the interaction between saddles typically are produced by, well, the homogeneous relation that appeared in previous talk. That is simply you have the stable and unstable manifold intersects transversely in some point, and when that you have a homogeneous point in the right, if you consider iteration of this manifold, you get much more homogeneous points. And this is more or less always that you have a homogeneous point, you have a horseshoe, and when you have horseshoe, you have homogeneous points. Well, and then, well, there is a class. Well, perhaps this may be unavailable for the younger. When we study dynamical system, starting in dynamical system in the 70s, 80s, you have axiom A. But when you have axiom A, it's because you expect to have axiom B. Okay, and then you have axiom AA and axiom AB, and there was a collection of different versions of axiom A, and this eventually, well, this now nobody pay attention to this thing. But the axiom A, what is a category of diffeos introduced by Smale and Jacob, you have that the non-Watering set, that is the set that concentrates all the recurrence of the system, to simplify, is hyperbolic, and the periodic points are dense there. And then the spectral theorem says that is a version of the Coley theorem for homeo and chain recurrent class, is that the dynamics, you can organize the dynamics using the periodic points, and then you have pieces of dynamics which are independent, and each piece is the closure, with the score homogeneous class, the closure of the transfer intersection of the invariant manifold of subside. This is more or less the way the people understand the hyperbolic dynamic. Well, as Enrique is not here, at least I have a slide with Enrique. This, you can see Enrique here in the in the right low corner. And then you see a Ricardo Mañé. Well, Mañé proved a proof of the C1 stability conjecture. I think that this is a talk that Enrique gave in Montevideo. I think that there are some people from Uruguay that can. And then, well, Mañé proved the stability conjecture. We are talking in the years 87. The years 87, there are years where the inflation in Brazil was about 1,000 something. And And then in this slide, I don't want to repeat what is it, but essentially, I don't want to go to the details. Is in the C1 topology. This is only known in the C1 topology. You have that the diffuse is structurally stable. That is, the dynamics of the diffuse don't change when you make a small perturbation. Is and only is the diffuse satisfies the axiom A. And this is explain the part where a diffuse is structurally stable, or you have a stability. The dynamics doesn't change when you the dynamics. Sorry, the dynamic doesn't change when you perturb a little the diffuse. You can have a conjugation. But Jacob was interested to understand what happened beyond hyperbolicity, which are the mechanisms that leads to the loss of stability, and also what happened when you lose the hyperbolicity. Well, let me just to explain that there are some bifurcations, which are bifurcation related to the when some hyperbolic periodic points, hyperbolic fixed point, to simplify my life, of our life. When you have a fixed point that is hyperbolic and lost the hyperbolicity, there are three main types of bifurcation. One is the scope bifurcation that only occurs in dimension 2, when you have a complex eigenvalue equal to 1. Or you may have bifurcation of saddle node when you have a periodic point that has an eigenvalue equal to 1. Well, what happened, well, you also may also have flip bifurcation or the type of bifurcation. I don't want to go to the details. But what happened is that all these bifurcations may occur in an isolated way. For instance, today, other speaker talked about the DA. A DA is obtained when you start with an anosov diffuse. At some point of the anosov diffuse, you make a sudden node bifurcation, and then you immediately pass from anosov, that is hyperbolic category, to DA, that in dimension 2 is also a hyperbolic category, but only have one isolated bifurcation. That is the transition between the two regimes. Well, Jacob was interested in bifurcation that imply a string of bifurcation. You have a bifurcation that cannot be isolated. And then one of the main topics of the research of Jacob was dedicated to the homogeneous tangencies, to the study of homogeneous tangencies when you have a saddle, this is dimension 2, so that the stable and the unstable manifold of the saddle have some non-transverse. This is working or not? Well, you see the red points, okay? This is a homogeneous tangency. Well, this is what happens when you are in dimension 2, a homogeneous tangency, or a cycle, if you want to put in more general setting. A cycle, you have saddles, so that the invariant manifold of the saddles intersects cyclically, but some of the intersection is not transverse. But in the figure on the top, you have one cycle, you have only one saddle, and the invariant manifolds have some non-transverse intersection that occurred along the orbit of the red point. But when you go to higher dimensions, you may have a more complicated, no, different situation, that you may have two saddles, the saddle P and Q. These two saddles have different types of hyperbolicity. The saddle P has two expanding eigenvalues and one contracting, while the saddles of Q have two contracting, one expanding. But you have that the two one-dimensional manifold, that is the stable manifold of P and the unstable manifold of Q, intersects as transverse as possible. But as we are in dimension 3 and 1 plus 1 is equal to 2, and 2 is less than 3, 3, you cannot have a second transfer intersection. And then, well, Jacob conjecture at some moment. I will talk about the Palis, the many conjectures done by Jacob. They conjecture that these two bifurcation where, if you are simplifying things outside the hyperbolic world, densely, you have these two type of bifurcation. Observe that, as you know, that the Kupka-SML diffuse are generic. This kind of situation cannot be generic. Well, and then, well, Jacob started a systematic way, or a systematic study, of study homogeneous tangencies and the bifurcation of homogeneous tangencies. You see here in a point that has homogeneous tangency. Unfolding the tangency means that you move the tangency below to create two transfer points. But as I told you, when you have a transfer homogeneous points, you have infinitely many. And if you look in the figure to the left, what happened? Well, you see that the stable and unstable manifold start to accumulate. And then what you have is that always that you have homogeneous tangency, you have also infinitely many new homogeneous tangencies. You cannot have infinite homogeneous tangencies isolated. And then one of the things that Jacob started to think is the following. Let me state in the super simple figure way. Take a family of diffuse. I don't want to explain what is generic, but you have a families that for t less than 0, you don't have the intersection. For t equals 0, you have this homogeneous tangency, and for t positive, you are creating two homoclinic transfer points, but you also have other parameters where you have other tangencies. And then more or less the philosophy of Jacob is the following. You have this parameter and you fix a property K. For instance, being hyperbolic or having infinitely many things, or there are many possibilities. And then you have PKT is the set of parameters in the interval 0t where you have the diffuse displace the property P. And then the two questions that Jacob started to do is, well, given the property K, what is the measure of the parameters satisfying that property? And if the measure is positive, what is the density at 0 of these parameters? You can put the link inf, link sub, because you don't know if the limit is it. And then, well, you may have many interesting properties. I will explain some of them later. And then, well, the simple question is, well, if, for instance, if you take K, the property of being hyperbolic, if this limit is 0, or when this limit is positive. Well, this is, well, and then let me try one of the things once you have a homogeneous tangency, which are the phenomena that Jacob considered associated to this bifurcation. Well, then, and this happens for many parameters, there are parameters where you have diffuse having infinitely many things. You have periodic attractors. I will talk about this in 2 minutes. You may have the parameters with tangencies. That means you have a hyperbolic set so that the stable and unstable manifold of this hyperbolic set have tangencies. Or you also, well, I don't know, this is like is a occurrence and persistence of string attractors. Well, I will explain these things in detail later. Well, in the 73s was a series, I think that this started in the 60s. there is a series of works of Sheldon Newhouse, culminated by this paper in the Publicación Mathématique de l'IHS, explaining that when you have a homoclinic tangency, you have many parameters where you have diffuse having infinitely many things. And the main ingredient in the proof of Newhouse was something that he called thick horseshoe. That is a horseshoe. Let me use the blackboard, the whiteboard. A horseshoe you have like this. This is a horseshoe, but you may have a horseshoe like this. If you are not understanding the figure, thinks that you have a Cantor set, and then you are removing the gaps of the Cantor set. In the relation between the gaps, I am not planning to define what is, and what is called the bridge. You know, the length of a bridge over a gap is big. You say that this is a thick horseshoe, and when the gaps are very small, you have horseshoes which are not thick. And then, well, the interesting point is that Newhouse related properties of the diffeomorphism, properties of the intersection of the invariant manifolds with properties of a kind of fractal dimension of hyperbolic set that he called thickness. And this, well, I am repeating this, sorry. The result of Newhouse, in few words, is that always that you have a diffeo that has a homoclinic tangency, well, I am assuming that the product of the two multipliers of the saddle is less than 1. If the product of the multipliers is bigger than 1, you need to replace things by repellers. Well, they prove Newhouse that's always that you have a diffeo with a homoclinic tangency, you have an open set whose closure contain the diffeo, so that in that open set, the diffeos having infinitely many things form a residual set. So that means that you have many diffeomorphisms displaying infinitely many things. And as I told you, the main ingredient to this proof is thickness. Well, and then in a series of works culminated by a book with Floris-Takens, you have here some of the papers that they published. They study in a systematic way the relation. You have a tangency that is associated to a hyperbolic set. Then, if this hyperbolic set has a small dimension, after the bifurcation, you will have prevalence of hyperbolicity. The frequency of hyperbolicity will go to 1. And if you start with a diffeo with a hyperbolic set that is with big dimension, what you get is the prevalence of non-hyperbolicity. Well, he started a series of very influential papers dealing with this. This was culminated by a book with Floris-Takens published in the 90s about bifurcation, bifurcation hyperbolicity. But I think that the interesting thing here is the subtitle of the book that has something about fractal dimension or something like that I forgot. Well, this finished some of the part, but on the other hand, in the 70s also, well, 78, Enon was a work on physics. He introduced the very famous these days Enon map, and in a paper by Benedict and Leonhard Carlson, they prove that when you have the quadratic family, this is in 2 dimensions because you have 2 parameters, the quadratic family exhibits NO-like attractors. An NO-like attractor, for the moment, is an attractor that is transitive as is not periodic, okay? As it's not hyperbolic, of course. Well, this is definition of a string attractors. You know, your string attractor has 2 parts, no? Attractor and strings. Attractor means that there is a neighborhood of the set that is attracted, whose the orbit goes to the set. And strings means that you have some point in the attractor. The orbit of this point is dense in the attractor, and the derivative along these points or the derivative of n has an expanding direction. You have a positively upward exponent if you want. This is what is really a string attractor. Well, the string attractor have a huge impact in the study of bifurcations. And well, I here explaining that the works by Leonhard Carlson with Jacob and Mike Benedict here, they prove that when you have the quadratic family, let me go backward. When you have the quadratic family here, the parameters corresponding to NO-like attractors has positive mesa. Well, and then I remember quite well when, well, this is also a small tribute to Jean-Christophe Jocot, a close friend and collaborator of Jacob. He puts the works with Flores and forward in this paper, but now I forgot what I was trying to say. Sorry. Sorry, 1 second. Well, let's go forward. I don't know. I plan to say something that I forgot. That happened. Well, in the yes, I was planning to say that I remember well that one day Jacob got the preprint by Benedict and Carlson, proving the existence of string attractors. And well, I don't have time to explain to this, but one of the tools developed in this book is the idea of renormalization. More or less say that always that you have homogeneous tangency, you have a process called renormalization, so that when you take the limit of this process, you are very close to the quadratic family. Super rough. And then, well, Jacob, I remember perfectly, talk with Leonardo Mora and Marcelo. They will appear in a few minutes. And say, well, if the NO attractors appear in the quadratic family, probably if you have a renormalization, you can recover this property for homogeneous tangency. If you say this in like this, it may seem very easy, but this is an extremely hard problem to go. And then, well, in the book of Jacob, they have in the chapter 7, they have an overview, and they explain which are the relevant phenomena associated to homogeneous tangencies. They include here cascades of homogeneous tangencies. That means when you have homogeneous tangencies, you will have infinitely many. And in each tangency, you also have another sequence of tangencies accumulated to this parameter. You have also what is called cascades of period doubling. You have a period orbit that then bifurcate to create an orbit of double period. This is related to the Feigenbaum cascade. You may have prevalence or hyperbolicity that appeared before. You may have infinitely many scenes, where I discussed briefly before. And you may have NO-like attractors. Well, and this is what Leonardo Mora is here at the left. You have Jaco and Marcelo Viana. They prove that once you have a homogeneous tangency like this, well, with some hypotheses, I don't want to go to detail, you have that the set of parameters T of diffuse having a string attractor have positive measure. Well, this was a really interesting result. They have many developments, but I have no time to discuss. But you see here Leonardo and Marcelo discussing and Jaco thinking. Well, let's try to see what is going on here. And then, well, what Marcelo and Leonardo wrote in his paper is that, that Jaco has proposed a program, for understanding homogeneous bifurcation, describing the reason of phenomena associated. I try to explain some of them. And also, they have another program about, that in the complement of hyperbolicity, you will have either tangencies, homogeneous tangencies of heterodimensional cycles. And then, well, Jaco have a third part of their conjecture, his conjecture, claiming that typically you have finitely many scenario or physical measures to say, but this is really a long-reach program. And then, well, in the 90s, Jaco started to make many conjectures. So I think that for me, the conjectures of Jaco provide a direction of research. Some of the conjectures were proved in some cases. Others are not completely true, but they are almost true. Well, but at least you are busy thinking about the program. I found the Jaco conjectures always extremely inspiring. And well, Jaco wrote two papers, one published in nonlinearity and another published in Asterisk. He emphasized that he wanted to have a global perspective of dynamics. He always insisted that he aimed to understand all the dynamics. Well, Jaco always thought in a bigger scale, as I told you, this conjecture of the denseness of infinitus on attractors, I think, is open till the current days, but there are many people working on this and getting some inspiration. Well, as I told you, the conjecture of hyperbolicity versus homogeneous tangencies. You are not in a hyperbolic regime. You will have density of homogeneous tangencies. This was proved in dimension 2, where you can only have homogeneous tangencies by Enrique Pujals and Martin San Marino. In dimension 3, there are some progress due mainly to Pujals and Crobizet, but it's still an open problem. Well, I say that the conjectures of Jaco was a source of inspiration or motivation. I think that without the motivation of Jaco, the book with Marcelo Viana left Christian Bonatti was impossible to write. Jaco always gave a lot of support. Let me say, that there are many things that we can thank Jaco. Well, Jaco create a school. He has many students. I don't know how many. How much? Infinitely many. You can see in this photo, you see Artur Lopez, Roberto Marcarian, Carlos Vasquez. By the way, I forgot to a quote to Carlos Vasquez that I like very much. When I organized the conference for the 80th birthday of Jacob, we collect some testimonies of people. Carlos Vasquez wrote that Jacob was the Rivellino of the mathematics. How many people know in this room Rivellino, please? Only the Uruguayans know Rivellino. Very few people. But you know, these people is worried about Neymar and this kind of these people. But says Rivellino, you know, Carlos Vasquez said Rivellino and not Pelé. Okay, because Rivellino was, this is being recorded, no problem, was much better than Pelé because sorry? No, because Rivellino play also in São Paulo. Come on. But also, let me finish. Rivellino have the capacity that everybody play the best with him. He has the possibility that everybody plays at the best when with Rivellino. He have the perfect situation, the perfect balls to the forward. He was great. Jacob was more or less in the Rivellino mathematics. With Jacob has the capacity of discovering in everybody his or his capacities and promote that. And then I think that this he didn't say Maradona or all these kind of things. And then, well, let me see. You have Carlos Vasquez, Leonardo Mora. I think that is Enrique Pujals, Jorge Rocha, Sylvain Crobizet, Rafael Abarca. Rafael Abarca was very proud that he was the 12th student of Jacob, and he decided that after the 12th, nobody count. You see Artur Avila is an intruder here. Marcelo, Eduardo Colli. I'm going Wilton, Pinheiro, Paulo Brandão, and Roger Bencher, that I think that is also an intruder. I think that he was a student of Marcelo, I guess, or not. Well, I am not sure. Well, he was welcome, okay, anyway. And then, as I told you, Jacob was a person that, besides mathematics, he was very involved in promoting science. Well, I talk about his role as president and secretary of IMO, organizer of infinitely many conferences, organizing INST Math, many conferences. He was also president of the Brazilian Mathematical Society during some years, and he was played a very important role in for promoting the bulletin of the Brazilian Mathematical Society. You see the 3 versions of the journal, the very old version. At some moment, the bulletin was published by Springer, that is in the middle. There was a reformulation of the bulletin, and to the left you see the current version of the bulletin. By the way, let me say that the Brazilian Mathematical Society is promoting a special issue dedicated to Jacob. We will prepare the announcement sorting. Everybody is invited to submit their contributions. Well, thanks. But in this slide, you have a special photo here. You see Jacob, Cesar, Marcelo, and this is Lorenzo. It's hard to recognize, but this is just two things. First, to recall that here in this photo, everybody is drinking. Okay, we have a cocktail now. And second, also, well, to thank, everybody, especially I, complain when Cesar asks about photos. He insists to take the photos in his way, repeat infinitely many times the photos. But I think that most of the photos I show is because Cesar has collected the photos along the years. And I think that this also a good moment to thank for collecting these photos. I say that he's more or less our official photographer. This is an important role in the community, you know. And then I will. Sorry, I am the child photographer. This was at least. No, I have time. 2 minutes. This another thing that Jaco made is to defend and promote younger mathematicians. This photo was made, well, was a sad moment, was a conference organized in Montevideo. This is a hotel, the most decadent hotel in Montevideo, that is a very high thing to say. This is my God, what is the name of this hotel? This is a Russian name. Hermitage, looks the name, Hermitage Hotel. This was after and Jaco at that time, Suhei Hayashi was claiming a proof of the conjecture, the stability conjecture for flows, and was a huge discussion about his other people make the proof before, blah blah blah. And I can remember perfectly in the whole of this hotel, Jaco having a very hard discussion with other people, say no, this result was proved by Hayashi, and he defend in the strongest terms the Hayashi contribution. I think that this is something that the young people, I think that are very lucky to count with the support of Jaco, and I will stop here.